Alright, so we're going to go ahead and see if we can kind of use and apply this idea of span. So Eve and Archer, who are Dr. Hershey's cats, are going on a trip for the first time. Dr. Hershey wants to help them on their journey, so she's going to give them two gifts. Specifically, she's going to give them two forms of transportation, a hoverboard and a magic carpet. Each of these have restrictions on how they operate. We're going to denote for the hoverboard, its movement is restricted by the vector 3, 1. So that means it can go, if it goes forward for an hour, it can move 3 miles east and 1 mile north of its starting location. Now, on the other hand, the magic carpet is restricted by the vector 1, 2. So if we travel forward, quote unquote, for 1 hour on the magic carpet, that means we're going to move along a diagonal path that will result from going 1 mile east and 2 miles north of wherever it is we started from. So Eva and Archer's first adventure is to go visit their cousin, Mako, who lives in a cabin that is 107 miles east and 64 miles north of their home. So we want to know whether or not it's possible to combine these two vectors in order to obtain this place. So if we're talking about 107 east and 64 north, that means this is the vector we're working with. So we want to determine whether or not this is possible. So I want you to take a minute, see if you can figure out how we'd set up this problem, and then give it a pause, try to solve it on your own, and then unpause it and see if you get it. And if you can't set it up, maybe just see how the setup happens and then see if you can solve from there. Okay, so if we want to go ahead and try to figure out how to get to this 10764, what we're really trying to figure out is how I can take some number a times 3, 1, so how we use the hoverboard, plus some number b times 1, 2, so how we use the magic carpet, and end up combining those in order to get to this 10764 place. Well, when we're looking at these, what we're going to do is we're going to compare the first entry of the vectors and the last entry of the vectors in order to make sure we have our equations. So let's do this addition. We get 3a plus b and a plus 2b, and this is equal to the 10764. Okay, so if we want to go ahead and put this as a system of equations, then we should get 3a plus b equals 107, and we should get a plus 2b equals 64. And so that means that we can, since we have a system of equations, put it into a matrix. So we get 3, 1, 107, 1, 2, 64. And if we put this into reduced row echelon form, this would be a good one to try by hand. We'll get 1, 0, 30, and 0, 1, 17. So that means A, or how long we should travel on the hoverboard, is 30 hours, and B, or how long we should travel on the magic carpet, is 17 hours. And that would be how we'd figure out how to get there. Alright, so a linear algebra way of asking that same question is 10764 an element of the span of 3, 1 and 1, 2. So suppose for some reason the magic carpet is acting up. In other words, we no longer have our vector 1, 2, and Eva and Archer can only use their hoverboard. Is there a way for them to get to Mako's cabin now? Well, no, because 107, 64 is not an element of the span of just 3, 1. So we can't just take 3 times 64 and get 107, nor can we take 1 times whatever 107 divided by 3 is in order to get 64. And so that, because we can't just use this one method of transportation to get there, we won't be able to get there if we don't have a magic carpet. So since we can't use the magic carpet, we want to go ahead and borrow from another magic carpet from Habanero's collection in order to get to Mako's cabin. So Habanero has many different carpets with movement restrictions. So they've got one that goes 3-1, they've got one that goes 6-2, they've got one that goes 1-3, they've got one that goes -3, -1. Archer doesn't want to go ahead and do too much thinking when it comes to figuring out which one they should use. Eva says that Archer could probably figure this out in his head. The carpet that they should borrow, go ahead and pause the video here and give it a shot, see if you can figure it out. In the end, if we borrowed 3-1, that's the same movement as we have with the hoverboard. So this one is going to be out. If we use 6-2, that's just a faster version of the hoverboard, but it won't give us any different ways of traveling, so that's out. And C4, similarly, is just going in the opposite direction. And so 1-3, C3 is the one we want to pick because it does something different than the hoverboard.